All right, guys. We are going to go over problems that should help you with IXL Section K, assignments 6 through 10. It's all about triangle congruence. But this time, we're going a little further into things than just proving the triangles are congruent. We might say something after that, or it might be a little bit more difficult to say they're congruent. But to start out, we're going to look at two triangles on the coordinate plane and figure out if they are congruent. So in order to do that, I have created a song that I would like to sing for you. I can just share my computer sound. And let's go. All right, welcome to the Mr. Field Jam session. We're going to find the distance and find the midpoint. X1 squared plus y2 minus y1 squared. Then you're done. Then you're done. Find the midpoint. Find the midpoint. Divide by 2. Just divided by 2. Plus x2, comma y1 plus y2, just divided by 2, just divided by 2. That's all right. Good job. Good job, Mr. Field, from a couple hours ago. So there we have the distance and midpoint formula. I'm going to clear that and go to my Zeitboard here. So in order to figure out if these triangles are congruent, we are going to need distance formula. And there are ways to prove that we have right angles on the coordinate plane if two lines are perpendicular, if their slopes are opposite reciprocals, but we're not going to do that right now. So let's see what sides are corresponding. Well, I could say that this side corresponds with this side, as one is straight horizontal and one is straight up vertical. Okay, so what are the lengths of these sides? Well, it goes from -1 to 9. So 9 minus -1 equals 10. That side length is 10. Okay, how about this one? It goes, oh, look at that. That's -9. That's 1. So this also is that's -10, but then when you take the absolute value, because we're talking about distance, we want to take the absolute value, and that would be 10. So side lengths are the same. We can say that CA is congruent to ZX. We got one side pair down, 2 to go. We can show the other two side pairs are congruent. These triangles are congruent by side, side, side. So let's go. Let's see about, how about AB? Okay, so segment AB. Well, what are the coordinates of A and B? So A is at 9, 2. And B is at 110. So I'm going to find the distance. And you can call either one x1, y1, and can't call it x1, y2 though. x2, y2. Okay, so now let's just subtract the x's. 9 minus 1 squared plus 2 minus 10 squared. Then I'm done. Don't forget to take the square root. Okay. So that's going to be 8 squared, which is 64. And this is -8 squared, which is also 64. So the square root of 128, right? That's what AB is. Which side corresponds with AB? Most likely YX. But now I'm starting to see that ZY does look a little bit smaller than BC. So we may have some issues here. But let's try XY anyway and verify whether or not these two are congruent. They are if we get the square root of 128 again. So X is at -9, -9, -9. And Y is at -2, -1. Okay, and I'm suggesting that XY is congruent to BA, right? AB. Okay, so let's see. So if we subtract the x's, we could get -2 minus a -9 squared. If we subtract the y's, -1 minus a -9 squared, all under the square root. Okay, and this is -2 plus 9, which is 7. And this is -1 plus 9, which is 8 squared. So 49, 64. What is that? 113. That's not good. XY equals the square root of 113. AB equals the square root of 128. And so does BC equal the square root of 113? Well, all right. I guess we do have to try. But at least we know now X, Y, and AB are not congruent. So there's only one chance left. What is BC? So let's do this. See how fast I can do this. I'm going to subtract the X. So 1 minus -1. And that's squared. And subtract the Y's. 10 minus 2. And so this is -1 plus 1. Is that right? -1 plus 1, which is 0. That's not good. And this is 8. So that's 64. That's 8. Is that right? Even if I'm wrong, it's not going to be the square root of 113. So XY is not congruent to AB. Bam, slash. And XY is not congruent to BC. So these triangles are not congruent. No. If they were, then we would have equalities for each side pairs. Okay. Let's move on to some triangle congruence proofs that are a little bit more in depth than in K1 through 5. So this one, we have an equilateral triangle, so I'm going to underline that because that means I'm going to probably see definition of equilateral in my reason section. And T is the midpoint of SU. There's another keyword. That's going to be a definition of midpoint, probably showing up for a congruent statement. And we want to prove that QTU, so now we got to know which triangles, that's QTU and RTS. A little check marks in the triangles that we're talking about. And we know this is equilateral. Okay, so triangle QRT is equilateral, that's given. T is the midpoint, that was given. RSQU. So that was marked in the picture. Wasn't written, but it's given because if it was marked in the picture for us, it's given. Now, TU and ST. There's TU, here's ST. Those are congruent because T is the midpoint. So I'm going to say definition. because I know which piece of given information is used to make that statement. How about this one? QT and RT. QT is right here. RT is right here. So those are congruent because this is an equilateral triangle. So that's going to be definition of equilateral. And then why are the triangles congruent? Well, we got three sides. Side, side, side. Now check this next one out. This one threw me for a loop the first time. And if it does again, I'm not stopping the recording. We're just going to count it as a teachable moment. These videos take a long time. All right, so RU bisects two different angles, SUW, so that means that these angles are congruent, and TRV, TRV, so that means these two angles are congruent. A bisector splits an angle in half. And so we're going to have definition of bisector if these congruent statements are used in the proof. Ultimately, we want to prove that RTU. Okay, RTU. Oh, I was like, why is it not changing the color? It's because I'm using the wrong annotators. RTU is right there. And it's right there. And RVU is right here. So these two triangles, why are they congruent? I see. So, okay. So we have one angle of each already. And we even have one side that they share. But what we need to get is this angle right here and this angle up here. So we have half of each one of those. What we need to do is figure out that these two angles are congruent. But are they? Yeah, because of the vertical angles, right? These are vertical angles. So they're congruent. And the other parts of them are congruent because of the bisector thing. And so, you know, we can kind of see what's going on here. They are going to be congruent. So let's just see what they did, and we'll fill in the blanks. VUW. Yeah. So VUW and SUT. Those are the blue angles there. So those are congruent because they're vertical angles. I'm going to say vertical angle theorem. RUW, that's the definition of bisector. We got that marked already. Choose color here. Okay, so now URV, where's that? URV, oh, that's going to be, that's these angles again. So that is the definition of angle bisector. Okay, now additive property of angle measure. We called it the angle addition postulate, but it's saying that RUV, which is the blue angle. Oh, so I said the vertical angles are calling those the blue angles. So the whole thing we'll call the green angle. Okay, so the blue is only going to be just that vertical, and then the green is the whole thing. So anyway, we're doing green for here. So these two are saying that the two smaller angles add up to the whole thing. And now, what is this here? We're substituting. Okay, where's RUV? Oh yeah, because two of the angles are congruent, you can just substitute RUS SUT, RUS SUT, RU W, V, U, W. So what do they do here? They got this angle, and they got this angle. And the first time they said RUW and VUW. But now they're saying the same thing as this one. And why can they say that? Because RUV, RUT, RUW. So because of the congruent statements we made up here, we know that in RUV, RUW, that's this angle right here, is congruent to SRUS. So because of the angle bisector. So we're just swapping out congruent angles. And then you can see that we have two different angles. And now we can see they have the same addition expression by substitution. You can talk more about that. But how do we now say that they're congruent is by property called the transitive property of equality. Okay, so what does that mean? There is a property that says if A equals B and B equals C, then A equals C. If two things are equal to the same thing, they're equal to each other. Well, here you can see RUT is congruent, is equal to RUS SUT. RUV is equal to RUS SUT. They're both congruent to the same expression. They're equal, so they're equal to each other. I said equality because we're talking about equal signs. And so I did skip a step by saying they're congruent because they're equal, but that's fine. And RU is congruent to itself, reflexive property. And now we can see angle, side angle. All right. You guys are welcome to put problems like that in the group organized worksheet. And hopefully I won't forget that. We should look at that in a minute. But now let's look at this proof. Not as hard, but you can see step 5 is that the triangles are congruent, which is where we've been stopping. But now we are going a step further. And so what that step is going to be CPCTC. And that means corresponding parts of congruent triangles are congruent. You have triangle ABC over here and triangle DEF, and let's say we prove that they're congruent. We got side angle side here. But what about this unknown side? Now that we know the triangles are congruent, we can also say that we have a congruent side over here after the fact by CPCTC, which is one of my favorite proofs because I get to say CPCTC. All right. So this is an odd one because we're starting with triangles being congruent, which is where we're supposed to end. But anyway, we're trying to prove that PQ is congruent to RS. Where are they? PQ is here, RS is here. Looks like a parallelogram. Okay. So the given information is that the two triangles PST, where is that? Right there, and RQT, those are congruent. Cool. So because they're congruent, PT is congruent to RT. CPCTC. Good example of CPCTC. QT is congruent to, that's fine, QT. QT is congruent to ST. So let me mark that in. QT, ST. Well, that's also because of CPCTC, because those are also congruent parts of those triangles. And, oh, we got vertical angles, okay. Problem. So where are they? PTQ, PTQ. Okay. So those two angles are vertical angles. And so now, why are the triangles congruent? We have a side, angle, side. So this triangle is congruent to this triangle because of side, angle, side. And so why are the two sides out here congruent? C, C, P, C, C. Got it? All right. And after you do all those proofs, guess what? You get a nice, easy assignment in K9. I think it's K9. We're talking about isosceles triangles, and there is the isosceles triangle base angles theorem. 1 year, called it ITBAT, and they fell in love with it because it had a fun name, ITBAT. So what does that say? In isosceles triangles, which means that the two sides are congruent, the base angles are congruent. That's the isosceles triangle base angles theorem. So an isosceles triangle, the definition is two sides are congruent. But guess what? Two angles are also congruent. Isosceles triangle base angles theorem. Okay, so which angles are the base angles? The congruent ones. The ones that not the vertex angle. This is called a vertex angle. And it's the included angle in between the two congruent sides. That is how you know it's the vertex. So this is 32, this is 32. And then of course, triangle angles add up to 180. So 32 and 32 is 64. Subtract that and we get 6. 1, so is it 116? All right. So have some fun with that assignment, and then you got one more. And okay, so we might be using ITBAT. Let's see, maybe not, but sometimes. Okay, so UX bisects, I might be using definition of bisector, VUW. So let me mark that in, VUW, I see you right there. Okay, complete the proof that, oh, so if we're proving angles are congruent, that sounds like CPCTC. And you can see it's after a triangle congruence proof. So it is. Oh, look, I didn't even have this. This is the reflexive property. And how about VUX and W? Oh, that's what I marked. And I knew that was because definition of angle bisector. Okay, so in the first video, I didn't use the statements and reasons from IXL. I just did it freehand. And so that is really what you need to do with proofs. But for this one, I used the IXL and filled in the blanks. And so hopefully that helps you complete these assignments as well. So post any question. Oh, wait a minute. Don't go anywhere. We have to look at the new organized worksheet. Only take 1 more minute, okay? So your homework now, so there's going to be an Ed Puzzle video up here, but I already posted the classwork part of it. You should still finish it before class. The reason it's called classwork is because we're going to use it in class. So this is a group Google Doc. So during the year, if you had me during the year, we had organized worksheets where you all did your own. Well, now we're not going to be that tedious. We're all filling in the same Google Doc. So everyone should put at least 2 problems in here. And it can be a problem you want to ask a question about. You don't have to be completely lost. You can just, you might be lost on one statement and reason, or you might just want to clarify, is this the only way I can do this proof? You know, just a conceptual question. So you put a problem in there that you want to ask about for some reason, you know, stir up the group conversation. And you might really feel comfortable on every part of an assignment and think like, because of the work you put in, maybe not everyone is yet. So you want to pick a problem to explain. I know some of you guys love explaining things, so you can put that in here as well. Okay, so the thing that's not listed that I know is on everyone's mind, what if someone puts a problem that they have a question about and I know how to explain it? Well, you can put that in the box, put, I would like to explain this one. So someone, student A puts a question in here that they want to know about, you know about it, so you're going to write underneath their question in that same box, oh, Mr. Field, can I explain this one? Okay, so we're going to give this a try and use this during the school year as well for different groups. So I will see you in class.